Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 20 minus 11. So, for my solution here, first start with 2 to the power of 20 minus 11. Now, I'm going to rewrite this as 2 to the power of 10 times 2 minus 11, because 20 is equal to 10 times 2. And now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, this is going to equal 2 to the power of 10 to the power of 2 minus 11. Now 2 to the power of 10, this is equal to 1024. So now I have 1024 to the power of 2 minus 11. And 1024, I can rewrite as 1000 plus 24 to the power of 2 minus 11. Now, if I have something in the form a plus b squared, this is simply equal to a squared plus 2ab plus b squared. So in this case, a is equal to 1000 and b is equal to 24. So this is going to equal to 1000 squared plus 2 times 1000 times 24 plus 24 squared. Now 1000 squared, this is simply equal to 1 million plus, I have 2 times 1000, which is equal to 2000, and 24 times 2000, which is equal to 48,000. So I have plus 48,000 plus 24 times 24, which is equal to 576. Now, if I add all of these, well, 1 million plus 48,000 is simply going to equal 1,048,000 plus 576. And 1,048,000 plus 576, this is simply equal to 1,048,576. So this is our answer. However, remember, we have this minus 11. So now I have 1,048,576 minus 11, which is equal to 1,048,565. Sorry, 1,048,565. So this is my actual answer. Alright, so I have 3 plus 3 is equal to 5. So we want to prove this statement to be true. So first off, let's say we have 0 equals 0. I'm going to start with this. We have 0 equals 0. Now for my left-hand side, 0, this is the same thing as 9 minus 9, right? Because 9 minus 9, anything minus itself is 0. And for my right-hand side, I'm going to rewrite 0 as 15 minus 15, which is also equal to 0. So I'm not going beyond the rules of mathematics here. This is just simple. This is just going by the rules. So now, 9, this is equal to 3 squared. So if I replace 3 squared with 9, I have 3 squared minus 3 squared. And now 15, this is equal to 5 times 3. So now I have 3 squared minus 3 squared is equal to 5 times 3 minus 5 times 3. And again, this is also going by the rules of mathematics. Now, an important property of algebra is that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And this is a very common property. So as you can see, in this case, for 3 squared minus 3 squared, a is equal to 3, and so is b. So now I have 3 plus 3 times 3 minus 3 is equal to 5 times 3 minus 5 times 3. Now, for my right-hand side here, I'm going to go ahead and factor out 5. So if I factor out 5, I get 5 times 3 minus 3. All I did was I divided 5 times 3. 5 times 3 divided by 5 is 3, and negative 5 times 3 divided by 5 is negative 3. So that's how I got 5 times 3 minus 3. Now, if I divide both sides by 3 minus 3, these two cancel out, and these two cancel out. So now I'll be left with 3 plus 3 is equal to 5. And as you can see, we just proved this to be right. 3 plus 3 equals 5, 3 plus 3 equals 5. So if you're wondering how this is actually wrong, well, it's because this step over here. I divided both sides by 3 minus 3. Well, what is 3 minus 3? 3 minus 3 is simply equal to 0. And if I come over here, I have 3 plus 3 times 3 minus 3, this is 0, is equal to 5 times 3 minus 3 is 0 as well. So now, if I divide both sides by 0, well, 0 divided by 0, that's not equal to 1, that's undefined. So you can't actually cancel these two out because these two are undefined. Dividing these two are undefined. So that's where this equation is actually wrong, and 3 plus 3 does not equal 5. All right, so I'm going to prove that negative 1 is equal to 1. So let's first start off with negative 1 is equal to negative 1. This is a true statement because any number is equal to itself, right? So now, negative 1, this is the same thing as negative 1 to the power of 1. Any number to the power of 1 is also equal to itself. So negative 1 to the power of 1, that's also equal to negative 1. And 1, this is the same thing as 2 over 2. So if I replace 1 with 2 over 2, I get negative 1 to the power of 2 over 2 is equal to negative 1. And 2 over 2, again, it's 1, so it's the same thing as negative 1 to the power of 1. Now, 2 over 2, this is the same thing as 2 times 1/2. So now, if I replace 2 over 2 with 2 times 1/2, I get negative 1 to the power of 2 times 1/2 is equal to negative 1. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So in this case, m is equal to 2 and n is equal to 1/2. So now I have negative 1 to the power of 2 to the power of 1/2. This is equal to negative 1. Now, if I have something in the form a to the power of 1/2, this is the same thing as the square root of a. So this is the same thing as well, first off, negative 1 squared, that's simply equal to 1, right? So now I have the square root of 1 is equal to negative 1. And the square root of 1, that's simply equal to 1. So now I have 1 is equal to negative 1. So I just proved to you guys that 1 is equal to negative 1. Alright, so in this video, I'm going to be solving the problem 2 to the power of 101 minus 2 to the power of 100. So to solve this problem, I'm going to first start by rewriting 2 to the power of 101 as 2 to the power of 100 plus 1. Now, the reason I did that is because now I can use this property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 100 plus 1 is going to equal 2 to the power of 100 times 2 to the power of 1. And now I have this minus 2 to the power of 100. Now from here, I can factor out 2 to the power of 100. So I get 2 to the power of 100 times 2 to the power of 1 minus 1. Now 2 to the power of 1 is equal to 2, and 2 minus 1 is 1, so I'm left with 2 to the power of 100 times 1, which is equal to 2 to the power of 100. Now, there is actually another method of solving this problem. So going back to the problem, I have 2 to the power of 101 minus 2 to the power of 100. Now, before I rewrote 101 as 100 plus 1, but how about I rewrite 100 as 101 minus 1? So now I get 2 to the power of 101 minus 2 to the power of 101 minus 1. And this is the same thing as 2 to the power of 101 minus 2 to the power of 101 plus negative 1. Now, if I use that property again that states that a to the power of m plus n is equal to a to the power of m times a to the power of n, I get 2 to the power of 101 minus 2 to the power of 101 times 2 to the power of negative 1. And now if I factor out 2 to the power of 101, I get 2 to the power of 101 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 101 times 1/2, which is equal to 2 to the power of 101 times 2 to the power of negative 1, which is equal to 2 to the power of 100. So that's the second method of solving this problem.